In this video, we're going to be looking at indices and 4 or 5 rules that you need to understand to be able to answer all of these questions. So let's have a look at our first example, x squared times x cubed. Okay, if I write this out in full, which you wouldn't necessarily do in an exam, but it can help you to see what's going on at first. X squared is x times x. Then I'm going to multiply, so this is the one in the middle, and then x cubed would be x times x times x. So squared means multiplied by itself twice here, and then cubed, we do it 3 times. If it was a 4, 4 times, and so on. And when we look at what we have in total here, we've got 1, 2, 3, 4, 5. X is multiplied by itself 5 times. And so we can use a little simple rule here. When you multiply things together and we have the same letter or number here, x, that could be a 5 and a 5, the powers are added. So 2 plus 3 equals 5. Let's try that with a number so you can see what that would look like. 10 cubed times 10 to the power of 4 would be 10. We keep the big number the same and we add the powers, like that. So we've come up with our first rule here. Multiplying means you add the powers. If it's the same thing, we can't do x squared times y cubed equals xy 5 or something like that, because these are different letters and it can only work if it's the same letter. If that was a y, then we could do it. If these were both x's, then we could do this, but not in this case. Okay, so this is our first rule, adding the powers. The second one, x to the power of 4 divided by x to the power of 2. Okay, I might change the first one actually just to make it a bit clearer. We'll change that to a 5. And again, if I write this out in full, this might help you to see what's going on in the background. X to the power of 5 is multiplying by itself 5 times, and we divide by x squared. And what happens when you do a division is that essentially we can cancel if there's the same on the top and the bottom. Okay, so a 1 and a 1 here. So 2 of the x's on the top have been cancelled out by 2 on the bottom, and it's left us with 3 on the top. X times x times x times 1 times 1 is x cubed, divided by 1 times 1 is just 1. Okay, again, you don't need to do this in an exam. It's just to show you what's going on in the background, because that can help you later on. But the rule is, when we divide, we subtract the powers. So 8 to the power of 17 divided by 8 to the power of 12 is 8 to the power of 17 minus 12, which is just 5. Okay, really complicated calculation to do otherwise, but when we have this rule, it becomes straightforward. Okay, and the division can sometimes look like this: x to the power of 7 over x cubed. And when students see it in that kind of fraction way, they don't necessarily apply this division rule. So this line here, it kind of looks like a divide, like there's something on the top here and something on the bottom. So in this case, we would do x to the power of 4, because we can just subtract the powers. Okay, the next rule that we need to be aware of is what happens if we have x squared cubed. Okay, so a brackets, and then the thing inside has been squared or cubed or power of 4 or whatever it is. Let's just have a think about what this actually means. X squared has been multiplied by itself 3 times. That's what the cubed is doing. It's taking the brackets and multiplying itself 3 times in this case. So something like that. Okay, and now we can apply our first rule, which is I'm multiplying, so I can add the powers, which gives me x to the power of 6. 2 plus 2 plus 2 is 6. And the shortcut rule is we can times these. So if we have something like 8 cubed to the power of 4, we can just simply times the powers. 3 times 4 is 12. Okay, that's our third rule. 2 more to go. They ask this a lot, especially in the non-calculator paper. What is x to the power of 0? Okay, and a lot of students will see this 0 and just go, oh, that's 0. And that's never the case. Anything to the power of 0 is 1. And you can test this for yourself with a calculator. You can take any number you like, and if you raise it to the power of 0, you always get 1. X to the power of 0. Oh, sorry, math error, because I haven't put a calculator value in. Let's do a 10 and press equals, and it will give 1. Doesn't matter what x is, it will always give a 1 here. So this is our fourth rule, and everyone seems to get this one wrong. They always put a 0 in here. We never say 0 as one of the answers. And then the final rule is to know that if you have a letter like X or a number like 17, there's an invisible power of 1 in there. So in maths, there's lots of invisible things. You know, there's an invisible plus here. There's an invisible 1. There's an invisible times. Okay, this is just an extra one that we have to be aware of. There's an invisible power of 1 in here. Okay, and why is that important? Because if we do x cubed times x, students will often put a 3 here because they think, I've got to add the powers, which is true, but they think, oh, there's nothing there, so it must be a 0, when in fact that is a 1, and so this becomes a 4. So x cubed times x becomes x to the power of 4. And that's where a lot of students will get confused. We have x cubed divided by x. They will do x cubed because they know that to divide you have to subtract, but they think that there's a 0 in there when it's actually a 1, and that would become x squared. Okay, so there are main rules for indices. Try to learn all 5 of those, and then we can start to apply those at the higher levels and use them in some more complicated calculations.